So we're going to be talking about the variable crimes we commit against JavaScript. JavaScript does quite a few odd things. And some of the things that cause people more trouble are unexpected behavior with variables. And a lot of us transition into JavaScript from another language and learn it on the job. We might have an opportunity to take some training on a particular framework we're working in, but it is very common for us to skip over vanilla plain JavaScript and not learn some of the fundamentals, and that'll bite us in the ass at some point. So, my name is Julka Grodel. I'm a principal software engineer at Framebridge. It's a startup in Washington, DC, and we are working on disrupting the custom art framing space. So we work both in e-commerce and manufacturing. An e-commerce site that sells custom frames at a third of the price of Michael's and ships them out to you in 3 days. And then on the back end, we actually build those frames, including for some of our moldings, sourcing wood and having it milled and taking care of that entire process. So we're using a lot of JavaScript, both on that e-commerce side and that manufacturing. And we do plan on coming to Canada and shipping at the end of Q2. But not yet, sorry. All right, so today we'll be talking about a bunch of things. We'll be talking about scopes in JavaScript for variables. We'll go over different types of functions, hoisting, closures, ways in which arrays and objects are special in JavaScript, and we'll talk about ES6. So you might hear ES3, ES5, ES6 thrown around JavaScript. ES stands for ECMAScript. It is a standard for programming languages that JavaScript implements. And so there are different versions of that, and browsers slowly implement more and more versions from newer versions of ECMAScript. So when we talk about ES5, we're talking about JavaScript that is available in most browsers right now. And ES6, sometimes you'll hear about ES7 now, is much newer features that many browsers might not support. On that note, most of my examples are going to be using var, which is ES5. And I will go into let and const at the end. The concepts that I explain with var will lend themselves very well when we talk about the differences with let and const. All right, so first of all, just a quick and easy way to play with some JavaScript in your browser, and that is your developer console. In Chrome, you can open that up with your view menu, going to developer and JavaScript console. In Firefox, it would be tools menu, web developer, web console. You can also open something up like this in IE and Edge and Opera, and in there be able to execute JavaScript right on the web page you're currently on in your browser. So that looks something like this. And we can use that dropdown to change exactly where we're seeing the area we can enter JavaScript. So down here, I've got it at the bottom. And right with this arrow, I can enter some JavaScript and run it right on that page. All right, so scopes. Here's a silly little bit of JavaScript. I'm going to set up a variable pink, and I'm going to put the value 1 in it. And then I'll console log out that value, and I'll get 1. I can also, at this point, ask for window.pink and get 1. Here is a small tweak on that. Now I am saying var, so var fuchsia equals 2. And I'll take a look at the value of fuchsia, and I'll get 2. And I'll ask for window.fuchsia, and I'll get 2. So no changes yet. And that is partially because we are dealing with one scope. And in order to set up some examples that will have multiple scopes and some weird JavaScript variable stuff happening, we're going to use a lot of immediately invoked anonymous functions. And those look like this. So they'll start off with a function, an anonymous function. And I'm not going to be using any parameters in mine. So I'll have open and close parens, and then my curly brackets. And in the ... whatever code I want to execute. So this sets up that function. I'll add in another pair of parentheses at the end to immediately execute that function. And to make my browser happy, I'll put parentheses around the entire thing and a semicolon at the end. So we're going to see this pattern a lot in the rest of the slides. And here is that first example. So in here, I have that immediately executed function and the code inside of it. And I'll send up magenta equals 3, and take a look at the value of magenta, and I'll get 3. Here I can take a look at window.magenta, and I get 3. I can then come outside of this function and continue executing code and take a look at magenta, and I have 3. And window.magenta, and I have 3. Still, nothing has changed. Everything has been predictable. In this one, I'm going to add var. And this is where we're going to start to see a change. So I'm going to go into this immediately executed function and set up var rouge equals 4. And then take a look at the value in rouge, and I'll get 4. Here, if I take a look at windows.rouge, I'll get undefined. And if I come out of this function, if I ask for window.rouge, I'll again get undefined. And if I ask for rouge directly, I'll get a JavaScript error that stops my code from executing. This happens because of this var here. With this var, what we're saying is that this variable, rouge, should only be available in that scope and child scopes, but not parent scopes. What I mean by that is var rouge will be available inside this function, but when I come out of this function, it will be gone. This function sets up its own scope. It will inherit from its parents when it doesn't have something defined specifically for its scope. But when we come out of it, we lose the variables that we set up inside that function. Here's a more complicated example of that. So I've got 2 nested immediately invoked functions, one up here and one down here. And I can go in here and define blush to be 5 with var in here. Then I'll come down here and take a look at blush in this nested function, and I'll get 5. I can go ahead and change the value on blush to 6, and now I'll get 6. I'll set up a var rows equals 7, and if I take a look at the value in rows, I'll get 7. Now, when I come out of this function, if I take a look at blush, I'll still get that 6. If I take a look at rows, that's gone. That would give me a JavaScript error at this point, because rows was set up here with the var in front of it. So it's only available in this function. Once I'm down here, I'm outside that function, and it's no longer available to me because it's not in my scope. If I come outside of both of these functions and I take a look at blush, I'll get that JavaScript error again. And if I take a look at rows, I'll get that JavaScript error again. And that's because rows is only available in this deepest function, and var blush is available in this first function. Now var blush is going to be available in its child scopes, like the inner function, but that is why we can no longer access it when we come out of both of those functions. Right? And so sometimes we'll do some code like this. It's a silly little if statement. It's always true, because true is always true. And so I might say, if true, execute this code. So if true, I'll set up a var of maroon to be 29. And if I take a look at my value in maroon, I'll have 29. However, when I come out of this and I take a look at maroon, I still have 29. So when we use var when setting up a function, we scope that variable to its parent function. If is not a function, and so we still have it available to us when we come out of that if. If we're not in a function at all, and we're at our global scope, our top-level scope, we might call that our window scope as well. That's when we find variables in that window object, so window.rouge. Then we would end up putting that variable into our global scope. And this becomes important when dealing with modern JavaScript frameworks, because we are dealing with function inside of function inside of function, turtles all the way down. We don't necessarily know where we are in relation to other code that's executing that we've set up, or what that tree looks like. And unintentionally affecting the scope of a parent can cause you some very difficult to track down bugs later on. So here, I do that with anonymous functions. You can also do that with named functions, where it's one inside another, inside the next, and so on. All right, so pop quiz. Let's apply some of that. Here, I'm going to set up a var amber of 11 and go into an immediately invoked function and set up a var amber of 12. What do you think we'll get here? I'm hearing lots of 12s. And that's right, that one's going to be a 12. How about this one? Yep, that one would be an 11. You all are very good at this. Here's another example, a little more complicated. I'm going to set up a var pumpkin to be 13, and then I have this function orange and a function tangerine. Down here I'm going to call orange. I'm going to set pumpkin to 14, and then come down to tangerine. So in here, tangerine is going to console log out pumpkin. What do you think we'll get at this point? 14. That's right. All right. And here is an example of an anti-pattern. So I'm setting up a function ginger and a function paprika, and then calling ginger, which will set window.peach to 15, and then calling paprika. What do you think we'll get when we call paprika? Right, so what we get here is we get that 15. And that is because window, when we add things into that window object, what we are saying is that they will be available to us at our global scope. In this example, assuming we have no other code on our page, everything out here and down here is our global scope. And Peach will be available there as just Peach as well as window.peach. Since this function doesn't set up its own Peach, it is going to use its parent scope's Peach, which in this case is our global scope, our window. And so what we've done is basically set up Peach here. That gets used down here. This is an anti-pattern. People will use this to communicate across components in very different places that are doing things in their own scopes. Or if they're working with other libraries and they're not quite sure how to pass things. It can cause you a lot of headaches, though. It is important to understand what's happening here because you are likely to find some code that does this. All right. Here I'm setting up a var mandarin, and I have a function apricot. Inside of apricot, I set up another var mandarin, and I have a function persimmon. Inside of there, I'll set up a mandarin 18. Here I'm calling persimmon. I'm going a bit out of order. So we set up apricot, and we call apricot. We set up mandarin again, and we set up persimmon. We call persimmon, and then we end up in here. So we have a var mandarin equals 18. What do you think we'll get back from this console log? 18. That's right, that's an 18. How about this one? I hear some 18s and some to this, where we take chocolate and we put a function into it. It's actually somewhat different. This is an anonymous function, and we're talking about a named function. So there is going to be a difference there in how the browser compiles it, but this is the correct order things happen in. And after that, we get to the code where we were actually calling chocolate. So we started off with something in a very different order and got it flipped on us, and a little bit of extra code added on top of that. And that is why I can call the function chocolate before I've defined it. All right, closure. A lot of programming languages give us closure. It's a way of setting up some variables and controlling who has access to them and who can change them. So we might give you access to a function that does some counting and some incrementing, but not give you access to the variable where that's actually tracked. Other languages will call these private or protected variables versus public ones that you can get in anywhere. And JavaScript scopes give us a way of creating closure. And here's a quick example of that. I'm setting up a var marmalade to be a function. And inside of var marmalade, I set up var caret and started off at 0. I'm also setting up a var greater than 2, and that's a function. What that function will do is it'll take caret, it'll increment it. So 0 will go to 1. And then we return a Boolean. We'll compare caret against 2. If caret is greater than 2, we'll return a true. If caret is smaller than 2 or equal to 2, we'll get a false. And then this function returns the function greater than 2. And so here, I'll say var salmon equals marmalade and execute marmalade. And what we'll get from that is greater than 2. I'll have access to greater than 2, but I won't have any direct access to caret. And I can come down here and call salmon. Salmon will go through. Salmon is greater than 2. So I will go into that function greater than 2. Caret is currently 0. We'll increment it to 1. 1 is not greater than 2, and we will get a false. We can call it again and go through greater than 2 again. Caret is now 1. We'll increment caret to 2. 2 is not greater than 2, and so we get another false. And if we go through it a third time, we'll get a true, because now caret will be 3. It will have been 2. We'll increment it to 3. 3 is greater than 2, finally, and we get a true. So through all of this code, we have affected the value in caret, but we've never had direct access to it. We can't take a look at what the value is if we've lost track of how many times we've called it. And that is closure. Now I can also set up another variable, so a var pink, and make it what comes back when I execute marmalade, and then I'll get a whole new caret and a whole new greater than 2 that track independently. All right, arrays and objects. So JavaScript is object-oriented. Everything we deal with in JavaScript is an object. We might have a string where we ask for the length of that string. Say we'll take the variable for that string .length, then we'll get back a number. We might have functions on that string. We do have functions on that string that we can use, like substring, to grab certain characters out of that string. This is an object. But if we ask for the type of this string yellow, what we'll get back is string. We might ask for type of 7, and we'll get back number. If we ask for the type of true, we'll get back Boolean. And so these are string objects and number objects and Boolean objects. But we just call them strings and numbers and Booleans. Here I'm going to set up an object. So curly brackets are how we denote objects in JavaScript. And so I'm setting up an empty object and asking for the type of it, and I'll get object. So now we have an object. It's a very helpful terminology, I know. And here I'll set up an empty array. So we use square brackets to define arrays in JavaScript. And here I'm just creating an empty array and asking for the type of it. And here I get object. So arrays are also objects in JavaScript. Not at all confusing, I know. Now, if I want to know whether or not the object that I'm dealing with happens to be an array object, I can ask array.isArray and pass it. Here I'm passing an empty array, and I'll get it back a Boolean. So a true if it's an object, false if it's not. And here I get a true. All right, so here's an object. Not an array object, an object. I'm going to set up var canary. And so a canary is a bird. I'm going to give the property type bird, and it flies. So I'll say flies equals true. And then I'm setting up a var bumblebee, and setting that to be canary. But a bumblebee isn't a bird. It does fly, but it's not a bird. It's an insect. I'm going to say bumblebee.type equals insect. Now, what do you think we'll get out when we take a look at the value of canary.type? We're actually going to get insect. So when we deal with objects in JavaScript, we're actually dealing with them by reference. Many languages will give us ways of intentionally passing our variables in as objects. For example, in PHP, you might put an ampersand in front of the variable when you pass it into something. But in JavaScript, that automatically happens with objects. So what's happening with canary, in this part, we're actually setting up an object somewhere in memory. And it has that type bird, and it has flies true, and it is somewhere in memory. And then we take a pointer to where that lives, and that is what we put in canary. We're not actually putting the values more directly there. And when we say var bumblebee equals canary, we're taking that pointer and copying it over to bumblebee. So we do have two variables. We have bumblebee and we have canary. They both have the same pointer to one object. And when I say bumblebee.type and saying take the pointer in bumblebee, go find that object wherever it is, find the type property and change that to insect. But we're only dealing with one object for both of these variables, and so canary.type is also affected. Here's an array. We have a var daffodil with the values 1, 2, 3. And I'm going to put daffodil and orchid, and then push another value, a 4, onto orchid. If I take a look at what I have in daffodil now, I have 1, 2, 3, 4. So arrays are objects, and they are treated by reference just the way the previous one was. So up here, we're setting up an array, putting it somewhere with these values 1, 2, 3, 4, taking the reference to it and using that in daffodil. Then we're setting up orchid and putting the same reference in orchid. And so both orchid.push is affecting that one array that we have with two different names. Now with arrays, there's some very straightforward ways in vanilla JavaScript to just make a copy of the array you're working with. So for example, I'll use slice. I set up cactus to be 1, 2, 3, and then I call cactus.slice. Generally, slice takes 2 parameters, the spot in the array where you want to start, and how many items from that array you want from that spot. So I might say stop at spot 2 and give me 2 items. And I'd get a whole new array back. However, if I call it without any parameters, it will simply make a copy of that array for me. And dandelion will be a whole new array that has the values 1, 2, 3, 4. I can push onto dandelion, that value 4. And if I take a look at cactus, I still have 1, 2, 3. And with dandelion, I have 1, 2, 3, 4. This does get a little uglier when you're dealing with arrays of objects, because all of those objects that you've put in the array are actually references. But you still end up with a completely new array of the same references. Unfortunately, making copies, there's many ways to do this. Slice is just the first one that came to mind to me. If you're working with a JavaScript library, it might have one that it suggests to you. Unfortunately, it is not as straightforward to make copies of objects. But if you are working with a library or a framework, it probably has a function that it encourages you to use if you're doing that. All right, ES6, let and const. So let, very generally, there are some differences, is a replacement for var. It works very similarly to var. And here, I'll set up a let green equal 21, and I can go in and I can change the value of green to 22. Here's const. The idea with const is that it's a constant. Once you put a value in it, it's not supposed to change. So I'll set up const sage to be 23. And then I'll come in and I'll change the value of sage to 24. And here I'll get a JavaScript error, and my code will stop executing because I have changed the value in something that wasn't supposed to change. This does have some performance boosts for us. If the browser knows it's never going to need to change the value in something, it can be more efficient with it. And it's also very helpful if you want to make sure code later on doesn't change something that's supposed to be static. All right, here is another const. I'm going to set up a const lime and set it up as an empty array. And then push to lime the value of 25. At this point, I can console log out the value in lime, and I'll get an array with one item, which is the number 25. If I come down here, and I now say lime equals this array with this value of 26, I will get a JavaScript error. Now, the reason this works at all in the first lines is because we are never changing the reference that we are saving in lime. So up here, when we're setting up that empty array, we're going and setting it up an array somewhere and then taking a reference to that empty array and putting it in lime. When we push the value 25, we're not actually changing the reference in lime, we're just adding something to what that reference points to. And then we can take a look at that and see that it's this array, it's the same reference, but it has different content now. So it has the value of 25. Why the last line breaks is over here, we are setting up a whole new array. We're putting it in memory somewhere, we're giving it one value inside of it, that 26, and then we're taking the reference to this and trying to put it in lime. And that's when we're actually changing lime. And that's what we're not allowed to do with constants. Here's an object. So we have const fern, and I am going to set it up as an object with one property, a name of foo. I can then go in and change that name from foo to bar. I can add another property, the number 27. And all of this is OK. We haven't, at this point so far, we have not actually changed fern, because fern is a reference to where that object lives. But we have used that reference to go and change the underlying object. Now, at the last part, here, I'm going to try and use the same values we already know are in fern, a name of var and a number of 27, and put that in fern. And here, I'll get a JavaScript error because I'm setting up a whole new object. Even though it has the same properties with the same values, this is a whole new object, and I'm taking the reference to this and trying to put it into a constant, fern. We had an example earlier with var like this, with an if statement, a silly little if true. Here's how that works with let. So I'm going to say let olive equals 28, and we'll go into this if true, and we'll set up let olive to be 29. Then if we console log out olive, we'll get 29. And if we come out of this if statement, we'll also get our original value, that 28. The reason for this is while var gets scoped to its parent function, let gets scoped to the current code block. And that if statement is a code block. So it has its own scope with ES6. Now we might do this sometimes to limit extra variables that are available in our scope. We might set something up and have a bunch of iterators that we're not going to use again, and so we might want to go into an if statement and do all of that, so we can't pollute our area. Or we might use that iterator again later, and we don't want to need to make sure that we reset it to 0. Has anyone gone from I to J to K to L in programming with iterators? Yes, so with let and code blocks, we can avoid that because we know that that variable is not going to come along with us. However, that if true is really silly. And so ES6 lets us set up code blocks like this. We can completely leave out that true and make code blocks wherever we want them with curly brackets. So this works the same as the previous example. We'll set up moss as 26, and then we'll set up moss again as 27. If we take a look at that second moss, it's a 37, and when we come out of that code block, we're back to our 36. And as I mentioned earlier, this becomes really valuable for iterators. So here's a for loop. I am setting up emerald and initializing it at 30. So let emerald equal 30. Here is how I'll be evaluating this for loop and when to break out of it. So as long as emerald is smaller than or equal to 34, we're going to keep going through this loop. And each time after we go through this loop, we'll increment emerald by 1. And so the first time we go into this, we'll set up emerald as the value of 30, and then we'll come in here because emerald is smaller than or equal to 34, and we'll console log out of 30. Then we'll increment emerald, emerald plus plus, so emerald is now 31. We'll evaluate again here. 31 is still smaller than or equal to 34, and so we come into that console log and we'll console log out 31, and then 32, and 33, and 34. After 34, we increment emerald again, we get 35. 35 is not smaller than or equal to 34, so we finally have a false, and we break out of this for loop. If we come down here and try to take a look at emerald, we'll get a JavaScript error because it's only available in this code block here because we defined it with a let. Here's the same code with a var and how it'll behave slightly differently. So we would find ourselves console logging out the same values, 30, 31, 32, 33, 34. After 34, we increment emerald to 35. 35 is not smaller than or equal to 34, so we break out of our loop and we make it down here. Here, when we take a look at the value emerald, we'll still get that 35 because that var is scoped to its parent function, or if it has no parent functions, the window scope, and so it sticks around outside of that for loop. All right, functions. I've talked both about named and anonymous functions, and here they are more clearly the difference. So in named functions, we'll say something like function and then the name, pair, our parens, and our curly brackets, and the code we execute each time. That's what a named function looks like. Those are the ones that get hoisted. And then we have anonymous functions. The var pair part of this is optional, but we'll set up that function. We won't give it a name, and we'll have it do whatever we want. Now we can either execute it immediately, like those immediately invoked anonymous functions that we've been using so much, or we can put it into a variable to use whenever we want. And now we'd use pair in both of these instances in the same way going forward. But there are some differences in what you can do with these functions. So named functions. They're created using that function declaration, and they're added to your current scope, whatever that is. You don't have access to control where that will end up. They're hoisted and defined early, and they are defined differently. The browser will set them up, but it will not actually go through the code inside of them at that pass. And that means that by the time it does go through the code inside of them, the function has been defined, which means we can use recursion. They are also very useful for debugging because you'll see the name of them in the call stack of how you got to the error that you're seeing. With anonymous functions, they're created using the function operator. They're available in the same scope of whatever variable you put them in. So if we define them this way, where we say var shamrock, it's going to be available in that current scope, similar just as that named function was. But we could have defined shamrock earlier in a higher level scope, and then just said shamrock equals without the var, and it would be available to us outside that scope. And if you don't want it to clutter up your current scope, you can simply execute it right away and not put it in a variable in that scope. With that, you don't have a way to call it later on if you want to use it again, but that can still be very helpful. So the variable gets hoisted in that first run through the code, but it doesn't actually get declared and defined until the place where you defined it in the code, which means we can't recurse with these. You can't call it until after you've defined it. Now we can mix the two to get the best of both worlds. We could say something like var shamrock equals function shamrock, parens, curly brackets. And I will have an example where I go over the benefits of that and some tricks about that. Right, so here's a mix of the two. We've got an anonymous function and a named function in here. So I set up this function shamrock, which will console log something out. And then I call shamrock, and we'll get out good luck. If I come outside of this, all of this and call shamrock, I'll get a JavaScript error because it is only available in the scope in here. Here's just a little tweak on that. So I put my call to shamrock in another immediately invoked function. So this is another scope. So I have 4 scopes that I'm working with in this. I've got the outside scope. Got the scope of this outside function. I have the scope in shamrock, and then I have the scope in this anonymous immediately invoked function. However, shamrock is available in the parent scope for this, and so if I come in and I call shamrock, I'll still get my good luck. And then I can do it out of order because it's a named function here. So I define my function here, but I call it here, and I'll still get my good luck because of that hoisting, where things are actually being evaluated by our browser in a different order. All right, so here is a way to do recursion with a named function, but still control the scope where that function is available. So I earlier talked about a var shamrock equals function shamrock. Here I'm doing var mint equals function basil. Now, the name I use here will only be available to me in this scope, but I can call basil. So now I've got a function that will just keep calling itself. If I console log out mint, I'll see that it's this function basil that calls basil. But if I try and call basil directly, I'll get a JavaScript error. That's because basil is only set up for a scope that is inside this function. So it's very straightforward if you name it the same thing. If you name it something different, you should know that you can't use a mint recursively in here because it hasn't been defined yet, but you can use basil because of how that hoisting happens in our browsers for JavaScript. So ES6 has all sorts of interesting things that we can go off and create new fun patterns with. But how is browser support? So this is just a screenshot from earlier this week from caniuse.com for ES6. And it is browser support for const, which is pretty good. It looks like 97.93% of browsers are going to support this. And so if I'm only supporting IE 11, I'm good. But if I need to use IE 10, I can't use const. Edge 15 would be a problem. Safari 10 would be a problem. But the newest versions of all the browsers are pretty good with const. Here's another ES6 feature, JavaScript modules and script tags. Support for that isn't quite as good. So I think we're 60%, 68%. Completely out of pocket for IE. And any Opera Mini, any UC browser and Samsung browser. If we're on Edge 15, we're in trouble. So how can you start writing JavaScript code that is modern JavaScript code now, even if you have to support some of these older browsers? And that's transpiling. So JavaScript is a scripting language. We don't compile it, but we can transpile it. The most popular tool for this, and the only one I've used, is Babel. And you can tell Babel what kind of JavaScript you want to target with your code. So I can tell it that I need to run ES5. But then I can go on and write ES6. And what Babel will do is change any place where I have ES6 only things to actually use ES5. When my customers catch up, or when the browsers that I have to support all support the type of code I'm writing, I remove Babel. Or I can change the settings on Babel. Maybe now we transpile down to ES6, but we're writing ES7. And that allows us to continue moving with JavaScript and write the newest JavaScript while still supporting users who are lagging behind on older browsers. This is a good article on how JavaScript transpilers work and how they can be helpful. All right, so we've gone over a bunch of things. We've gone over scopes in JavaScript and how they bubble from child to parent. We've gone over the different types of functions, the named and the anonymous functions in JavaScript, and how they can be used differently. Hoisting, as well as the three-step process that our browser takes on JavaScript. That first step, pulling up variables that have been declared with var, let, const. Second step, pulling up those named functions. And the third step is actually executing the code. We've gone over closure in JavaScript, how arrays and objects are extra special objects. And we've gone a little bit into ES6. I do want to leave you with a couple more resources. Mozilla Developer Network is a great site. It's actually a wiki, so if you ever find something in there that's wrong, you can edit it and suggest changes. But it is a great source for finding documentation on certain functions in JavaScript and a lot of different things in web, information about SVGs or CSS, as well as information about what browsers support it in what ways. And CanIuse is similarly helpful for understanding what browsers support what and how. All right, thank you very much for coming out today. I'll take questions if we have any. All right, well, I am around. Oh, go ahead.
Just to make sure I understood, if you declare a variable without var, let, or const, is it available with window dot anything?
Only if nothing in any of its parent scopes has declared it with var, let, or const.
So if it's the only time you've ever used it, then it's available?
Yes, and that can get you in a lot of trouble.
Yeah.
Because you might change it in other places, not realizing that it's being used somewhere else for something else.
So the good practice is always to declare it somewhere.
Yes, and to start off with const, because you will get some performance gains from that, and then change it to a let when you need to change it.
Okay.
Yes?
I was wondering, and maybe this will show my lack of experience, but I was wondering, like, in what context would you use the same name of variable, like, in so many different scopes? Because doing this seems like bad practice or something, because this can very quickly become confusing. Now it's like studied cases, so it's good, they're all declared kind of in the same spot, but like in the code of hundreds of lines of code, like why would someone do that?
So we do want our variable names to be unique and descriptive, but at the same time, generally the best practice is to keep your lines to 80 characters because that's a lot easier to read. So we don't want to go very long in our variable names. Common examples of variables that get used over and over again are title or name. If you are iterating over something and then iterating over another array of the same kind of something, you might end up calling it the same thing, and you want to be sure you know what you're dealing with at what point. You can avoid a lot of this by just being more descriptive with your variable names and being thoughtful there, and you should definitely do that. But we still end up with situations where we have the same variable in a couple different places. Title and name are the most obvious ones. I is a very popular one for iterator. And if you're not being mindful about what scope you're making those available in, you can shoot yourself in the foot. Yes? The use of closure? The use of closure? So a lot of libraries that we might use to set something up will have some closure in them. They might make 2 or 3 functions available to us that do something we would want to do. For example, maybe we have a library that helps us with adding SVG elements onto our DOM, because that is XML. That is a little different than just adding a regular element on. And it might have some variables inside of it that it doesn't give you access to change. So for example, XML namespaces in that example, we'd have one for SVG itself, we would have one for Xlink. And those that library probably doesn't want to make available to you directly so that you don't change them. It's sort of protecting yourself against what other developers might do, and trying to reduce the errors of someone reaching into an object and changing things manually that they probably shouldn't. For me, for example, we would do that with something where we're pricing the cost for a frame for a particular art piece based on width and height. We wouldn't give someone access to the object that has the different boundaries of the different price areas. We would just give them a function that they call with the width and the height, and it will spit out their size group without giving them access to the entire thing. So we don't want that ever changing. Yes? I mean, it's a little, if you want to, yeah, if you want to control what scope it's available in other than your current one, I think it is shorter to write it as an anonymous function because you will set up that variable where you want it with a var or a let or whatever, var or a let. And then in the place where you're actually setting it up, you would put it in that variable. But you can also do that with a named function. It's just going to be some extra characters. I don't know about that. That's a really good question. I know a lot of JavaScript developers are very strict about always using named functions because it helps in troubleshooting. I'm not so strict on that. Also, we use a lot of anonymous functions when passing callbacks to other functions. So yeah, but we can use them in all sorts of horrible ways. All right, well, I will be around tonight. So if you want to talk any more JavaScript or have any questions, I would be happy to go over any parts of this with you. Have a great night.